Hi, and welcome to our study guide review problems. I've got a cat here that I'm going to be teaching to. She's hanging out next to me. We'll see if she lets me do all this stuff. So this is going to be a longer video, so you don't necessarily need to watch all of it. If you wanted to skip through to the problems that you want to see, the only ones I'm going to be covering from the study guide are the essential questions. Yeah, she's leaving. She knows if I'm recording videos, it's no point in hanging out. And I'm going to do, essential questions, 2, 3, 16, 17. I'm going to do 19 and 22, number 29, numbers 35 and 36, and then problem number 41. Okay, so these are the only problems that will be seen in this video. If you are looking for information about some of those other problems, please check out the filled in PDF study guide. That'll give you a worked out answer for those questions. So what must you get rid of to simplify a radical expression? My answer to this question is you are looking for perfect squares in the radicand. That's the thing that's inside of the radical, so anything that's underneath the square root is what we're trying to get rid of. Next, in a right triangle, which side is the hypotenuse? It is the longest side, and then it is across. So if you kind of picture my little screen, can I get a finger there somehow? No, backwards and weird. Okay, so you take my screen and then you cut it in half, right? And so then you've got this little corner down here. The one that goes all the way across my screen, that is the hypotenuse. So it's across from the right angle in that little picture. I figured that'd be a little sillier. Make sure you have both of those pieces of information. You need to know that it's the longest side, and you need to know it is across from the right angle. What will your answer look like when using the distance formula and when using the midpoint formula? The midpoint formula we did not cover. It's not in this distance learning stuff. So we're just worried about the distance formula. And the answer is it should be a square root. It should be the square root of some kind of number. So it should just be a square root. Make sure that that square root should be simplified as well. All right, so those are the essential questions. We're going to hop into some problems. So I'm going to start with number 2. Number 1 is very similar, so I'm just going to take care of number 2. So in number 2, we need to simplify that radical. And what I've always done with these radicals, and we want to break it up into those two problems. We've got a number and a variable. You want to separate them and treat them like two separate problems. You want to square root 81? Oh, that's easy. It's 9. Great. If you want to simplify a exponent, so if you're square rooting exponent on a variable, you want to cut that exponent in half. So if you've got some number up top, you want to cut it in half. But 3, if you cut that in half, you only get 1.5. So we want to break this up. We're going to break it up into the square root of m squared and a square root of 1. You're always going to do that for square roots. You're always going to make an exponent of 1 and an even number for those two things. So it's going to be the next even number right before 3. If that had been 7, we would have made it a 6 and a 1. But it's always going to be an even and a 1. That way we can cut m in half, or the exponent on m in half, and make it just regular m. The 9 is going to stay a 9. And for politeness and for correctness, we are always going to put our radical at the very end of our problem. Next problem, we've got 2 square roots of 6 minus 5 square roots of 54. We need to simplify that 54, and then hopefully we're going to be able to combine it. Now, I'm thinking ahead, and I'm like, hey, that's 6. Could we make it like a 6 and a something? I'm just kind of curious about that with 54. So 54 divided by 6. Hey, 9 is a perfect square, so we could break that 54 up into a 9 and a 6. Now, this is kind of a sneaky shortcut we're using because we're kind of have an idea that we're going to simplify this stuff. Otherwise, you could just like go through 54 and check its perfect square factors. So we're going to use 6 and 9. So we're going to keep everything else. So we got 2 square roots of 6 minus 5. We're going to turn that 54 into a 9 and a 6, those two separate radicals. So the 9 becomes a 3. We still got the square root of 6. And we have everything else. So 5 and then 2 square roots of 6. 5 times -3, that's -15 square roots of 6. And we got 2 square roots of 6. Now that those radicals match, the numbers inside of the radicals, we can combine those two things. Those are like terms. So we've got 2 minus 15, we get -13 square roots of 6. And we can only do that because they're both square roots of 6. If it had been a square root of 6 and a square root of 8, we would not have been able to combine them. Well, now that I say that, that square root of 8 thing, that could be simplified, but still, it wouldn't work. Wouldn't work. All right, next. We've got a fraction. So with those fractions, we want to remember we want to get rid of the square root in the denominator. Before we do that, I'm going to see if I can make my life a little bit better because, like I just said, ironically, the square root of 8, we can simplify that. So 3, and that's 72. I want to do the same thing. I want to find a perfect square factor of 72. So I do 72, and I know 81 is bigger than 72, so I shouldn't use that. So the next one is 64. How's that look? Nope, that's no good. 7 squared, that's 49. Nope, that's no good. 72 divided by the next perfect square, that would be 36. Oh, success. So we're going to break it up into a 2 and a 36. So square root of 36 and a square root of 2. And that's going to be all over that 8. And we can probably just do that one in our heads because the only perfect square that's smaller than 8 is 4. And we can do 8 divided by 4, so let's use that. So square root of 4 and a square root of 2. All right, let's simplify these radicals. So we've got 2 square roots of 2. And in the numerator, we've got 3 times the square root of 36, which is 6, and that's a square root of 2. Okay, I'm going to combine those. So we've got 18 square roots of 2 over 2 square roots of 2. Okay. Now, these do cancel, is what I'm looking at right now. We could do the square root of 2 divided by the square root of 2, and those just will cancel out. However, I do want to show simplifying the radical, so I'm going to assume I didn't see that, and I'm going to show how to get rid of that radical. What if those didn't cancel? Well, we'd multiply the top and bottom by the square root of 2. Square root of 2 times the square root of 2, that's just 2, so on the top we got 18 times 2. And in the denominator, we've got the square root of 2 times the square root of 2. That also becomes a 2. So we've got a nice real answer there. At this point, I'm just going to type that into my calculator just to save a little time. We've got 18 times 2 divided by 4, which is 9. Sweet. All set. Next problem, I'm going to do that distribution up top, which is kind of a complex distribution. There's so much going on with this thing that I'm actually going to write out what I want to multiply before I actually multiply. So we've got 2 square root of 5 is going to go to both of them. I'm going to do a little separator here. And we've got that 7 square root of 3. So this is that first multiplication. And then we've also got a second multiplication where we multiply by 9. And we still have our addition in the middle. When we multiply our stuff together, over here, all that really happens is the 2 and the 9 get multiplied together. So we get 18 square roots of 5. And then in our second piece over here, our 2 and our 7, the things that are outside of our square root, those get put together. So we get 14. And then we've got our square root of 5 and square root of 3. So that is the square root of 15. Since they're both in a radical, we're able to put them together. And then this is our answer 14 square roots of 15 minus 18 square roots of 5. We could check 15 for perfect square factors. I'm going to keep the video short and say that there are none. If you don't believe me, please check yourself. It's a good thing to check. 5 also doesn't have any perfect square factors. The only perfect square that's smaller than 5 is 4. 5 divided by 4 doesn't work out very well. Next. We're going to do a little solving. So these ones are equal to something. We've got an equal sign that tells us we can solve. So let's do that. So what I want to do first is I want to get the radical by itself. So I need to get rid of the 6 and the 3 that's with the square root of x right now. I'm looking at number 19. So first thing I want to do is I want to add 6 to both sides. So we get 3 square roots of x equals 9. And then I need to get rid of that 3, so I'm going to divide both sides by 3. So we get the square root of x equals 3. And then finally, now that the square root is by itself, now I want to get rid of that square root. Do not do it first. If you do it first, it causes trouble, so don't do it. Wait until the square root is all by itself and then square both sides. You cannot do it right away. And we get x equaling 9. That square and that square root undo each other. We can check this problem by plugging this 9 back into our problem up top. So I'm just going to copy the problem and put the 9 in. So 3 square root 9 minus 6. Let's see if that equals 3. The square root of 9 is 3. 3 times 3 equals 9. I'm running out of space. 9 minus 6 equals 3. Hey, yeah, 3 equals 3. We're all set. That check worked. All right, next problem. This one, the square root is already by itself. Yeah, sweet. So all we have to do is square to get rid of that square root. So we square both sides of this equation, and we end up with 7x minus 6 equals x squared. Now I have a quadratic in this problem. So to solve quadratics, which we did back in chapter 10 and chapter 9, we need to get this thing equal to 0. So I'm going to bring this 7x and the 6 over. The reason I want to bring the 7x and the 6 over is I like my squared term to be positive. It makes my factoring much, much easier. So we get 0 equals x squared minus that 7x plus 6. I'm going to factor this thing. You can do it with the box if you want. You can go back and check your box notes, or I'm just going to just kind of do this in my head a little bit. So I need something that multiplies to be 6 and adds to be 7. So I can do, 6 times 1. 6 times 1 will get me 7. And I want them to turn out to be negative 7. So they should both be negative. All right, this equals 0. So x equals 6, because 6 minus 6 will get us 0. And x equals 1. Now we need to be careful with these problems because we could get extraneous solutions. So it's important that we check to make sure that they both actually work. So if we do the square root of 7 times 6 minus 6, I want to see if that equals 6. So that is the square root of 42 minus 6. That is the square root of 36, which is 6. So hey, yeah, that works out. If we check the other one, I'll do it over here because I've got a little space. I've got more space over here, I should say. Seven times 1, that's 7 minus 6. So that's the square root of 1. Hey, the square root of 1 is 1. Cool. So both of them actually worked. We didn't have any extraneous solutions in this thing. Awesome. Sometimes we get extraneous there, sometimes we don't. Sometimes you feel like a nut, sometimes you don't. All right, what's our next problem? Um, let AB represent the legs of a right triangle. Let C represent the length of the hypotenuse. We need to figure out what the unknown side is. So we have to figure out what is C. So we just need to plug this into our Pythagorean theorem. That good old A squared plus B squared equals C squared. So they told us what A is. A is 9, so I'll square that, plus whatever B is, and we need to know what's C. They didn't tell us that. B is the square root of 12. So we want to square 9, that's 81. The square root of 12 squared, that square root and the square undo each other, so we're left with just the 12. My phone keeps buzzing. I don't know if you can hear it. And it's distracting. So I should almost put it on airplane mode or something. Next, we want to do 81 plus 2, so that's 93 equals C squared. And I want to square root both sides. Whoop, whoop. So we get C equals plus or minus the square root of 93. But since we're talking about a right triangle, and right triangles need positive side lengths, we're not going to worry about that negative. Now 93, I wonder if we could simplify that. So to the calculator. To the calculator we go. We check 81. How's that? Bad. We do 93 divided by 7 squared, so that would be 49. What do you think about that? It's bad. 93 divided by 6 squared, that's 36. How is that? Also bad. Oh man, I don't know if we're going to get anywhere on this one. But I wanted to show you checking just to be sure. I'm real doubtful. I got some serious doubts here. So 93 divided by 9. Yeah, what do you think about that? Nope. 93 divided by what else? 4. Nope. No perfect squares divide 93. So, well, one of them does. It's 1. But that doesn't do anything. That doesn't help us simplify our problem. So we're just going to leave it square root of 93. We're done. We do want to check to see if we can simplify every time. Next, we want to see if these are making right triangles, yes or no. So the way to do that is you want to put the longest side in for C. Now, I can tell that 16 is definitely bigger than 15, but I don't know if 16 is bigger than the square root of 61. So I better check really quick. How big is the square root of 61? I don't think it's very large, but I want to know what it is. Okay, so it's 7. So 7 is smaller than 16. So 16 is our biggest number. I might be sneaky. Like you can look at this one over here. Like you might be tempted to say that 12 is C. No, 72 is C. So we want to see if 16 squared equals 15 squared plus the square root of 16. 61 squared. Okay. So we go to our calculator, 16 squared, what are you? You're a pretty big number. 256. I actually know what 15 squared is. It's 225 plus 61. Actually, now I'm nervous. It'd be real embarrassing if I got that wrong. What do you think, calculator? Whew, I'm fine. Now I need to know what's 225 plus 61. I hope it's 256. Ah, dang it. That's 286. That's too big. Those are not the same. Since they're not the same, it's not a right triangle. Dang it. All right. Well, here, let's try this other one. Ooh, these are all numbers that they're not like square rooty things. So 7.5 is our biggest one. So we want to put that in the C spot. Since it's the longest side, we want to make sure that it is the hypotenuse spot. and the two shorter sides are over here. It doesn't matter which order you put them in. All right, now to the calculator, we're going to do 7.5 squared. See what that is. 56.25. I know 6 squared. I know that's 36. I don't know 4.5 squared. You got calculator. 20.25. Whoop. All right. So 56.25. I want to see. Hey, yeah, that does equal that. 20.5. 20.25 plus 36. That does equal 56.25. Check it on your calculator if you don't believe me. Oh, cool. So these are a right triangle because that works. That checked out. Can't spell triangle. Yay! Yay! Much success. All right. Next, what do we got? I think this is our last problem. We're going to find the distance between these 2 points. So to find the distance between these 2 points, I like to always label first. Ugh, label ugly. So we got x from our first point, x from our second point, and then we've got y from our first point and y from our second point. The distance formula will be written on your test, so you don't need to worry about memorizing it. You do need to know how to use it. So we've got our point labeled. So this is our x from our first point, y from our first point, x from our second point, y from our second point. We need to put those into the formula. I like to write everything out first, so I've got everybody, a place for everything, so I can put everything in its place. All right, so I need x from my second point. X from my second point is 6. Put in the 6. Then I need the x from my first point, which is the x from my first point is 1. So I'll put a 1 there. Then I need the y from my second point. The y from my second point is 7. So I'll put 7 there. And then we need the y from the first point. The y from the first point is -5. Having trouble remembering which one's x and which one's y, it's alphabetical. X comes before y in the alphabet, same thing in points. 6 minus 1, that's 5. And then we've got 7 minus -5, that is 7 plus 5, which is 12. I don't know why I wrote out 7 plus 5. So we got 12 squared. So this is the square root of 25 plus 144, which equals the square root of 169, which I happen to know to be the square root. Well, the square root of 169, I know that's 13. And that's our answer. That's our distance between those points. That's it for the video problems. Again, if there's problems that you need help on that you did not see in this video, you can go to Moodle and check out the completed study guide so you can see all the work needed. Please make sure that you're using that after you have completed your study guide. It doesn't do you any good to just go there and copy it down. What you should do is use it to check after you have attempted to do the problem yourself. Thanks for watching. Yeah, thanks for watching.